Hi, girls and boys. Welcome back to our science lesson for today. We've got a few things to go through, but I actually want to start by having a look at your results from last week. So if you haven't done last week's science lesson, make sure you go back and do that first before you try this one. Okay, but anyways, I'm assuming now that you have done that, we're going to have a look at the results of your votes, or what you voted for, whether things were a solid, liquid, or gas. So I'm just going to switch over to my computer here. Now, I've just included a few pictures just for reference, but here we have, I'll zoom in a little bit more. Here we have the first one, which was stones. I had a bunch of stones. You guys know stones. They're basically rocks. This is more of a boulder, but that's just a big stone. Okay, it's stone. And you had to vote if it was a solid, liquid, or gas. And the correct answer is a solid. You guys got that, so that makes sense. A stone is a solid. Very simple and straightforward. But then we get to one that's a little bit trickier. And then I had icing sugar. Icing sugar is a bit harder because it's very soft. It's not hard, okay? And I was able to sort of pour it. And it requires a little bit more thought. But the truth is that icing sugar is actually also a solid, okay? Now, solids, I guess, don't have to always be hard, perhaps. But the reason we can actually prove this is a solid in that if I zoom in with a magnifying glass or a microscope in this case, you can actually see that every little piece of sugar is a little solid shape here. Okay, now they're so small that they can tumble over each other and pour down when I pour them. But each individual one can't be poured. That one there is going to stay its own solid shape. Okay, unless something breaks it, it's going to stay that. It can't pour that little cube. It's just so many of them it looks like they can pour, but it's not really. So icing sugar is a solid, and there are the icing sugar crystals to prove it. Okay, let's keep going. Next up, we had honey. Honey's a cool one. It is a liquid, but it was quite different to water or something like that. We can swim in water, but I don't think we could swim in honey. That would be an expensive experiment, but still a cool liquid, very thick. Okay. Next up, I had this elastic band. I used like an exercise band. I've just got the picture there for reference. These bands are very stretchy. Okay, they were quite soft and squeezy, but they are also a solid. They are not a liquid, and we'll find out exactly why as we explore them further. Okay, so solid for the elastic bands, or the lack of bands. Next, we had cooking oil. Cooking oil was more of an easy one. This is a liquid. Okay, cooking oils can be made from different things, olive oil or sunflower oil or things like that, but they are liquids. They're thicker than water, but not as thick as the honey is. Okay, there's a special word we'll use for that soon. Okay, now the next one is salt here. Now, salt is a little bit like the icing sugar one from before. Okay, salt, I was able to pour it very easily, but really I'm not pouring like a stream of salt in the same way that I would water. It's actually just lots of little tiny bits falling out. So if we were to zoom in on them, we can actually see here's a single cube of salt. It's actually its own little rock. That little crystal of salt can't pour. It's just when there's so many of them, it sort of looks like it. Okay, it's just the same way that the wood chips at the port, they pour out of the back of those trucks and things like that. But that doesn't make them liquid, does it? Okay, because each individual wood chip is clearly a solid piece of wood, just like this grain of salt. Okay. And next up, I had the air. Now, the air was our only example of a gas. Now, this cup technically is not empty. It is full of air. Okay, we're going to do some experiments on that later. But for now, that one, I'm not talking about the glass, no, the actual air inside the glass, that was our gas. Okay, So that was the only one that we can vote gas on. After all that, I put this one in just to confuse people. That being said, a lot of people are very familiar with slime these days. It's really become popular the last several years. But slime is a combination in a sense. It's both can behave as both a liquid and as a solid. So really, you could tick both of them to give the right answer. This is what we'd call a non-Newtonian liquid. So it's actually got properties of both a solid and a liquid. Now, you don't really need to know non-Newtonian liquids for our, our tests or anything like that, but it's a common question we get. Which one is it, a liquid or a solid? It's got some of both in it. If you've ever actually made some of your own slime, then you'll know exactly what I mean. Okay, so you could tick both of them for that one. Okay, that was the last one there. Okay, you guys did really well, and I had a lot of great thoughts coming from many of you students on those topics, so that's really good. Okay, so now we're going to move on to today's task. Okay, so today's task up on Google Classroom is this new sheet called Exploring Liquids. Now we've got a few questions. We've got a bit of some observations, sort of experiments I want you guys to do at home, as well as some videos to watch at the end. Okay, so let's have a look. I've got 3 parts to it. The first part, okay, is where you're actually going to have to get your parents' permission to go and get some water, some honey, some oil, and you can get some sugar. Okay, now you don't have to mess them up or do anything. For example, I've got some oil here. You can even just leave it in the bottle. You can look at it quite clearly and quite well just in the bottle to get an idea. Okay, I just want you to have those at hand because they'll help you come up and answer these questions. Okay, and help you come up with some ideas. All right, you're going to examine them and attempt to answer these following questions. Now note that I've put sugar on here, but it is not a liquid, as we learned before. So if you get sugar and pour a little bit onto a plate, you'll see it makes a pile. Okay, it's not a liquid, but having it there helps you see, gives you a comparison. Okay, so these questions I want you to answer yourself. Have a think about them. What do you think are some facts about liquids? So get those liquids you've got at home, some honey, some oil, some water. Look at them carefully. What are some facts about liquids in general? Now, for example, we can't say all liquids are clear, because that's actually not true. There are many liquids that are not clear. We can't say all liquids are like water, because honey's not really that much like water. Okay, so have a think about it. You tell me some facts, okay, about what do you think all liquids have. Just write some thoughts in here. Get a bunch of it. Put a sentence or 2 in here, okay? Afterwards, are there any liquids that don't have water in them? Name them. So this is going to require a little bit of thought, okay? Maybe you even want to do a tiny bit of research, okay? That's fine. Okay, you might... Now, I'm not going to give you any clues. I want you to think about that one, okay? Have a think. All right, remember, you can look at those ones you've got in front of you and ask yourselves the same question, examine them. Then you've got, what are some liquids that are thick? Okay, now by thick, I've given you one already, which is like honey. Okay, even oil is thicker. So, have a think about it. What are some liquids that are thick? And then afterwards, what are some liquids that are thin? Okay, so a thin liquid is just water, plain old fresh water. It's much thinner than honey or oil, if you know what I mean by that term. Okay, so thicker things are sort of sticky and slower. Okay, where thinner liquids would run really fast and splash around much easier. Okay, have a think, see if you can name any. How many other liquids do you know? All right, put those in there. Okay, now remember, you've got those water, honey, oil, and sugar. Examine them so you can get a good idea of this next part. Okay, after your careful thought and examination with those liquids, answer these questions. Okay, the common properties of liquids that I found are, okay, now what that means is, what do all liquids have in common? Think of every liquid you know. What do all of them have? Okay, all of them must have something. And whatever it is, for example, liquids, we can pour them. Okay, can you pour all the liquids you know? Yeah, if so, put them in there. Okay, think of anything that all liquids can do or all liquids have and put it there. Next, what are some of the things that are different between liquids? Okay, we know lots of different liquids. We've thinking about them. What are some things that are different from one to another? For example, are all liquids the same color? No. Write that there. They don't all have the same color, so put that down. Okay? Now, at this point, I actually want you to stop this video, pause this video, and answer those questions, because I really want you to get a chance to actually be a bit of a scientist here and do a bit of experimenting, a little bit of observations of your liquids and some thought. This is a big part of scientists, asking ourselves questions and looking to try and discover those answers. Do that part of it as best you can. All right? And then when you get back, we'll do the next part. Okay. All right. Hopefully you paused it and you've finished part 1, and now we're on to part 2. Okay. Now, part 2 is where I sort of give you some of the answers to these other parts, and hopefully you'll actually have come up with something that is similar to this through your understanding of all these questions before. So this is basically where we write the definition of a liquid. Now, if we were at school, we'd be putting this in our glossary and stuff, but we're just going to put it in here for now. We can create a new glossary when we get to school as a good way of doing some revision. But write a definition of a liquid. I've already written one. I'm going to throw it in here. Okay, I want you to put this down on your document as well. Write this in your document. Okay, a liquid is a substance that flows freely. Okay, all of our things like honey and oil, they flow freely. They just flow. However, if I have salt and I just pour it on a table and make a pile, it doesn't flow down and away, does it? So it's not really flowing freely. Okay? But a substance that flows freely but is of constant volume, that means it always takes up like the same amount of space. You'll see why that's important later. Okay? But if the liquid takes up this much space, it will take up that much space if I pour it into a coffee mug. It still will take up the same amount of space. Okay? And last of all, it takes on the shape of its container. If I pour it into a container like this that has these funny shapes, it will become that shape inside the bottle. Okay, so there are the 3 parts that a liquid needs, that the definition of a liquid needs. It flows freely, it takes up the same amount of space, and it becomes the shape of whatever container you keep it in. If you pour your liquid into a pool-shaped container, then it will be the shape of a pool. Easy. But if you pour a big hunk of rocks into a pool, it won't necessarily fit that exact shape. Okay? All right. Last of all, I've got a new word here, which is viscosity. You're going to write this one in as too. Now, viscosity is actually the scientific word that refers to how thick a liquid is. Okay, so water does not have much viscosity because it's very sloppy and splashy. Where oil has a bit more viscosity because it's still pretty sloppy, but it's not as sloppy as water is. Like it's doesn't splash as much, it's thicker. Where last of all, honey has a lot of viscosity because it flows slowly. So it has a lot of viscosity. So we're going to write this in here. Okay. Viscosity is a liquid's resistance to flowing. Meaning how much does it resist flowing? How slow does it flow. If something has a lot of resistance, it flows very slowly. Now that's an important word when we talk about liquids because some liquids have more or less viscosity. Bit of a weird word, practice saying it. Okay, once you've written those two definitions, the last part is nice and easy. I've actually put a section here of some interesting liquids that I want you to check out. Now I've said to check out 2 or more of these, so at least 2, but you might actually want to check them all. They're pretty interesting. Okay, so quickly I've got a magnetic metal liquid, so a liquid that is actually also a magnet. Quite interesting. We have lava. Lava is a liquid. Okay, and let's see, does it make sense? Does it flow freely? Does it take up the same amount of space? Okay, and does it take on the shape of whatever space it's in? Yes, it does. So lava can also be a liquid. Then we've got liquid nitrogen. Now I have 2 here about liquid nitrogen, just because I found 2 interesting videos. They're pretty easy to watch, and you might want to check those out. Last of all, no, not last of all, next I've got mercury. Okay, mercury is something that used to be in thermometers for us to tell the temperature, but we don't put them in thermometers anymore because it is actually a poisonous metal. And you can actually see in that video where he actually touches the mercury, and I think that was a pretty silly idea. So you don't ever touch mercury. I mean, technically, as long as your skin's perfectly formed, but I mean, if you just had a little bit of scratches around your fingernail, you could get mercury poisoning. So anyways, that's mercury. It's pretty interesting. Then I've got something different, liquid salt. That one's cool. And last of all, nitroglycerine, which is a very dangerous liquid. Okay, so have a look at 2 or more of these, and at those times you can see how they match the 3 different parts of what makes something a liquid. Okay, boys and girls, yeah, get all this done, submit it in to me when you're finished, and I look forward to seeing you all guys next week. All right, thanks a lot, guys. Bye.